6.5 goes over solving exponential equations. So you already know how to solve linear equations. Now we're going to work with exponential equations, which just means we have a term raised to a power. That base number that's being raised to that power has to be the same on both sides in order for you to solve these. If they're not, you need to make them the same. So once both of those bases are the same, you can actually cancel out those bases and just work with the exponents. So if we look at example 1, we're given 3 to the power of x plus 1 is equal to 3 to the power of 5. We see that our base of 3 is the same on both sides of those equal signs, so we can cancel out those 3's and just work with those exponents. So we're solving x plus 1 is equal to 5. Again, solve this like you normally would. We're going to undo that addition by subtracting 1 from each side, and we get that x is equal to 4. So just like linear equations, when we solve those, if you get an answer and you want to check it, you can plug it in, and you should get the same exact answer or a true statement on both sides of those equal signs, and you know that your answer is correct. For example B, we're given 6 is equal to 6 to the power of 2x minus 3. Here, your bases are the same, but the 6 on the left side does not have a power on it. So automatically, what's not going to change that value of 6 if it's raised to a power? 1. So this is the same exact thing as saying 6 to the first power is equal to 6 to the power of 2x minus 3. So you have the same base on both sides. Those 6's will cancel each other out, and you'll just work with the powers of 1 and 2x minus 3. So we're solving 1 is equal to 2x minus 3 since those bases canceled out. We're going to undo addition or subtraction before we undo multiplication or division. So we'll start this one by adding the 3 to both sides. The 1 plus 3 gives us 4 is equal to 2x. From here, we just divide each side by the 2, and we get that x is equal to 2. For example C, we are given 10 to the power of 3x is equal to 10 to the power of 2x plus 3. We see that those bases are 10 on both sides, so we can cancel them out and just work with the 3x is equal to 2x plus 3. From here, we can subtract the 2x from each side. We bring down that 3. Oops. There we go. These cancel, bring down the 3. So we're going to have x is equal to 3. For example D, we're given 2 to the power of 2x is equal to 2 to the power of 6. So again, our bases are the same on each side. We can cancel out those 2's and just work with the 2x is equal to 6. We're going to divide each side by that 2 to get x by itself, and x will equal 3. For example E, we have 5 to the power of 2x is equal to 5 to the power of x plus 1. So once again, those bases of that 5 are the same on each side, so they can cancel, and we can just work with the 2x is equal to x plus 1. From here, we're going to subtract the x from each side. We're going to be left with x is equal to 1. For example F, we have 7 to the power of 3x plus 5 is equal to 7 to the power of x plus 1. So again, bases are the same. We cancel those out. We work with the 3x plus 5 is equal to x plus 1. I'm going to move this x over first by subtracting it from each side. That 1 drops down, that 5 drops down, the x's cancel. So this is leaving us with 2x plus 5 is equal to 1. From here, I'm going to subtract the 5 from each side to get my x on its own. I'm going to have 2x is equal to negative 4. And then to isolate just the x, we're going to divide each side by 2. And we get that x is equal to negative 2. So the next part of your lesson goes over these bases that are not the same. When you do not have the same base on each side, you can turn it into the same thing. So it'll be the lower of the two numbers, and it'll be raised to a power. So for example, with example 2a, we have 5 to the power of x is equal to 125. Well, 125 can be 5 to the power of something. 5 to the second power is 25. 5 to the third power is 125. So we're going to change this 125 to be 5 to the power of something. So we're going to have 5 to the power of x is equal to 5 to the power of 3, because 5 cubed is 125. From here, now our bases are the same. We can just cancel out those 5s and work with the exponents. And we just have x is equal to 3. So that would be our solution. For example B, we're given 4 to the power of x is equal to 2 to the power of x minus 3. Now I'm just going to rewrite this to where it's 4 in the parentheses raised to the power of x is equal to 2 in parentheses raised to the power of x minus 3. The reason why I do this is so that way I know that whatever my base is, it's being raised to that power. So when I change either the 4 or the 2, that whole term is going to be raised to that power. I look at these two bases. I have a 4 and I have a 2. Which of these is going to become something to the power in order to give myself the same base? Well, 4 to the power of something will never be 2 to the power of something. 2 is the smaller of the two numbers, and 4 is a multiple of 2. So you can do 2 to the power of something is equal to 4. 4 is the same thing as 2 squared. So we're just going to rewrite this as 2 squared raised to the power of x is equal to 2 to the power of x minus 3. That 2 squared to the power of x, what happens when we have a power raised to a power? We multiply. So we have to multiply the 2 times the x to give us our power. So this becomes 2 to the power of 2x is equal to 2 to the power of x minus 3. Now we have the same bases on each side that are being raised to powers, so those 2's can cancel each other out, and we'll just work with the 2x is equal to x minus 3. From here, I'm going to subtract the x from each side. We get x is equal to negative 3, and then we're done. If we look at example C, we have 9 to the power of x plus 2 is equal to 27 to the power of x. Now, with these, the smaller of your two numbers is 9. However, 9 is also something to the power of something. So what can you turn that 9 into in order to make it a number raised to a power? 3 to the second power, right? So this 9 turns into that 3 to the second power. So we're going to have 3 squared raised to the power of x plus 2. Now that 27, can we turn it into 3 to a power? Well, 3 cubed is 27, so we'll change that to be 3 cubed to the power of x. Now from here, I'm just going to simplify those powers. Remember, I have a power raised to a power, I multiply. With that 3 squared to the power of x plus 2, you are distributing that 2 in. So we have 3 to the power of 2x plus 4 is equal to, then the 3 cubed times to the power of x, 3 times x, gives us 3 to the power of 3x. From here, we have the same bases on both sides, so cancel out those 3's and work with the exponents. So we'll have 2x plus 4 is equal to 3x. From here, I just got to get x by itself. So I'm going to subtract that 2x from each side. Bring down that 4. I have x is equal to 4. For example D, we have 4 to the power of x is equal to 256. Now this one, you can do one of two ways. So 4 can turn into 2 to the second power. The 256 would be 2 to the 8th power. However, 256 is also 4 to the power of 4. So you could either use a base of 2 or a base of 4 with this. It's totally up to you. I like working with smaller numbers, so I would use the base of 4. So I'm going to turn this 256 into 4 to the power of 4. So we're going to have 4 to the power of x is equal to 4 to the 4th power. Once again, my bases are the same, so they cancel, and I just have x is equal to 4. If I wanted to do it as the 2, I would just have 2 to the 2nd power raised to the power of x is equal to 2 to the 8th power. From here, this would give me 2 to the power of 2x is equal to 2 to the 8th power. The 2's would cancel, so I would have 2x is equal to 8. I divide each side by the 2, and I get that x is also equal to 4, doing it this way as well. So again, it's totally up to you which way you want to do it. I like working with the smaller numbers or less steps, so that's why I chose the 4, but again, it's totally up to you. If we move on to example E, we have 9 to the power of 2x is equal to 3 to the power of x minus 6. So I can turn that 9 into 3 to the 2nd power, so I'll do that. It becomes 3 to the 2nd power raised to the power of 2x is equal to 3 to the power of x minus 6. That 3 squared to the power of 2x becomes 3 to the 4x power is equal to 3 to the power of x minus 6. Our bases are the same, so we cancel them out, and we just work with the 4x is equal to x minus 6. We're going to subtract the x from each side. We get 3x is equal to negative 6. Then we divide each side by the 3, and we get that x is equal to negative 2. For example F, we have 4 to the power of 3x is equal to 8 to the power of x plus 1. That 4 can be simplified to be 2 to the power of 2, and that 8 can be simplified to be 2 to the 3rd power. So I'm going to just change these both to be 2 squared raised to the power of 3x and 2 cubed raised to the power of x plus 1. So again, I'm going to simplify those powers. 2 squared to the power of 3x is going to become 2 to the power of 6x. And 2 to the power, 2 cubed to the power of x plus 1, I'm going to distribute that 3. And I get 2 to the power of 3x plus 3. So now that my bases are the same, we can cancel them out and just work with the 6x is equal to 3x plus 3. I'm going to subtract the 3x from each side. We get 3x is equal to 3. Then we divide each side by the 3, and we get that x is 1. The last part of your lesson goes over solving these equations when one of your bases is less than 1. You got to remember those negative exponents. So like if we look at example A, we have 1/2 to the power of x is equal to 4. That 1/2 is still the same exact thing as 2 to the power of something. In order to have gotten that 1/2, that power would have had to be negative. So it's just 2 to the negative 1st power. So we would change that 1/2 to the power of x to be 2 to the power of negative 1 raised to the power of x. And that 4 is the same thing as 2 squared. So with that negative 1 and that x, we're going to multiply them. We get 2 to the power of negative x is equal to 2 to the power of 2. Our bases of that 2 are the same, so we cancel. We get negative x is equal to 2. From here, just divide each side by that negative 1 to make x positive, and x is going to equal negative 2. For example B, we have 4 to the power of x plus 1 is equal to 1 over 64. That 4 is just 4 to the power of, you can also turn it into 2 to the power of 2, totally up to you. However, the reason why I'm not changing that 4 into 2 to the power of 2 is because 64 is 4 cubed. So that 1 over 64 would just be 4 to the negative 3rd power. So if I did that, I would have the base of 4 on the left side as well as the base of 4 on the right side. So because my bases are both 4, they can cancel out, and I can just work with the x plus 1 is equal to negative 3. We would subtract the 1 from each side, and we get that x is equal to negative 4. For example C, we have 1/3 to the power of x minus 1 is equal to 27. That 1/3 is the same thing as 3 to the negative first power, and that 27 is the same thing as 3 cubed. So this is going to give us 3 to the power of negative x plus 1. We distributed in that negative 1 is equal to 3 cubed. Our 3 as the base is the same on both sides, so cancel them out. Just work with the negative x plus 1 is equal to 3. We're going to subtract the 1 from each side. We get negative x is equal to 2. From here, we divide each side by negative 1 to make x positive, and we get that x is equal to negative 2. For example D, we're given 1/4 to the power of 3x is equal to 64 to the power of 2x plus 2. So we said before that 1/4 is like saying 4 to the negative first power, and that 64 is 4 cubed. If we wanted to turn these 4s into 2 to the power of something, we could do that instead. I'm going to work with the 4, so I'm going to just do the negative 1 times 3x to give me 4 to the power of negative 3x, and the 3 times 2x plus 2, which is going to give me 4 to the power of 6x plus 6. My bases of the 4s are the same, so I'm going to cancel them out and just work with the negative 3x is equal to 6x plus 6. I'm going to subtract the 6x from each side to get my x values on the same side. I'm going to have negative 9x is equal to 6. From here, we're just going to divide each side by that negative 9 to get x by itself, and we get that x is equal to negative 2/3.